Hi, welcome to lesson 5.4, Solving Rational Equations. The goal of today's lesson is to connect the solution to a rational equation with the graph of a rational function. And the reason why we're going to do that is so that we can verify that the solution to a rational expression is equal to the zeros of the rearranged equation of the function. So let's get started, shall we? First of all, we want to state the restrictions before we start solving here. And remember that when we are solving rational expressions, or when we have a rational expression, whatever's in the denominator, that cannot equal 0. So what we have to do is the restriction would be that x cannot equal 1 in this case, because if x were 1, that would make the denominator 0, and that would become undefined. Okay, so then now what we need to do is we've got this expression x plus 3 over x minus 1, and that equals 0. And the nice little thing we can do here is we can multiply both sides by the denominator. That's supposed to be a bracket. There we go. And then we will just x minus 1 divided by x minus 1 cancel, and 0 times x minus 1 is just 0. So we're left with x plus 3 equals 0. And then when we rearrange this, we get x equals negative 3. So what I'd like you to do to verify this by looking at the rational function is what I'd like go to Desmos and put the left side of this equation into Desmos and see the graph there. And then I'd like you to put this equation in, no, sorry, not that one, this one here. X plus 3, put in y equals x plus 3. So then you'll get that line that would result. And then take a look at where the graph, both of the graphs would cross the x-axis. Okay, so then we can verify that this rational function, the solution to this, is the same as the 0 of this equation here. Okay, so y equals this, substitute that in, and then y equals this, left side, so that you can graph both of those in Desmos.com, and then you can verify that the solution to both of those is x equals negative 3. Alright, moving right along to example B, we've got x minus 6 over x plus 5 equals 2. Restrictions, we can't have the denominator equal to 0, so we're going to set the denominator, we're going to say that the denominator cannot equal negative 5. And so then we will just begin the process now. And so we'll write this x plus 5. And again, we want to get rid of this denominator, so we're going to multiply both sides of the equation by x plus 5. And x plus 5 divided by x plus 5 just cancels and just leaves you with 1. So on the left side, we're left with x minus 6 equals, and I'll just expand this in at the same time, 2x plus 10. And then we'll just rearrange the equation here, so I'll subtract 2x from both sides, so I get negative x. I'll add 6 to both sides, so I get 16. And then I divide both sides by negative 1, so I get x equals negative 16. Okay? So that's the solution to this. What I'd like you to do again, verify. Now in this case, when you go to Desmos, graph y equals x minus 6 over x plus 5, and separately graph y equals 2. You'll see that this function here will cross y equals 2 at x equals negative 16. And then just to also verify that, graph y equals 6 minus x, sorry, x minus 6, and graph separately, or like in the second function, y equals 2x plus 10, and see where those intercept, and they will intersect at x equals negative 16. Well, we're going to verify that, and hopefully that is true. Okay, so verify those by graphing in Desmos, please. Now we're going to move along to something a little bit more challenging. So here we've got an addition now, so things are going to, the challenge is going to be increased a little bit. So this is just a constant, 3, so it's not a big deal. We can leave that. Now here, there could be an issue there. So for the restriction, we'll say that x cannot equal negative 3. And so then, now we need a common denominator. Just like over here, now we only had one denominator in the first example and the second example. So that's why we multiplied both sides of this equation in A and both sides of this equation in B by the common denominator, which was x minus 1 in example A and x plus 5 in example B. We're going to need the common denominator here. Now, a lot of times students may say, oh, it's just x because here's a 3 already, I can just add x to that. Well, unfortunately, that is not the case. We're going to have to get a common denominator of 3 times x plus 3. Okay, so the thing that we're going to multiply through by, we're going to multiply everything by 3 quantity x plus 3 by everything. So we're going to have 10 over x plus 3 plus 10 over 3 equals 6. And everything gets multiplied by 3 times x plus 3, because that would be the common denominator. And then we just expand things out. Now again, x plus 3 divided by x plus 3 just cancels. Over here, 3 divided by 3, those just cancel. And now we're left with 3 times 10, which is 30, plus 10 times x plus 3 for the second term there on the left. And then here I'll get 18 times x plus 3. And then I'll start to simplify this a little bit more. So I'm going to have 30 plus 10x plus 30 equals 18x plus 54. And simplify this side, so I get 10x plus 60 equals 18x plus 54. Then I'll rearrange this a little bit more. And I subtract 18x from both sides, so I'm going to have negative 8x here. I'm going to subtract 60 from both sides, I get negative 6. Divide both sides by negative 8, so I get 3/4, which would be the solution. So, again, go back into Desmos, please, and graph this y equals 10 over x plus 3 plus 10 over 3. And graph y equals 6 in the line below it. And we'll see where this graph crosses y equals 6. And then what I'd like you to do is down here graph y equals 10x plus 60 and y equals 18x plus 54, and see that the solution to this, where the intersection of these two graphs is the same as the intersection of these two graphs, which would be at x equals 3/4. Okay, and just one more example here while we continue this journey.